Hey everyone, it's been a while, hasn't it? Welcome back to another edition of Chemistry Outside of the Classroom. This might very well be the last video ever made. We'll see. So feel free to smash and like comments. All right, here's the deal. Unit 7 test is coming up, so I thought I'd kind of throw you a warning bark as to what's coming your way. Feel free to watch this, feel free to not. Anyways, it turns out that there's pretty much three skills you're going to need to know. Skill number one, you're going to want to know how to predict the products of these three type of reactions: synthesis, decomposition, and combustion. So remember, when we're talking about products, we're talking about things like AB for synthesis reaction. So if you have A plus B, what are the products that you get, right? And remember, these could have numbers next to them. It could be A2, B3, for example. For decomposition reactions, we want you to take kind of the opposite of synthesis. So we're going to give you AB, and then this is going to be blank right here. You're going to have to fill in A plus B. Again, B could have a 2 next to it if it's a sneaky 7, for example. Lastly, combustion reactions will give you a formula of C with some number next to it, H with some number next to it, plus O2, and then an arrow. You're going to have to fill in CO2 plus H2O. Combustion reactions kind of easy, right? The products are always the same. They're always CO2 and H2O. What's difficult, though, is going to be balancing them. Balancing is actually skill number 3 that you're going to have to learn, right? So below here, I've got a couple example problems. This first one, for example, doesn't even have actual elements next to it. But kind of the idea is you're going to want to make sure that you have the same number of A elements, the elements in red on one side, and B elements, the elements in blue on the other side. And we'll work through these three together. The other thing that you're going to have to do is I will write out a reaction and I will say, what type of reaction is this? And the options will be A, synthesis, D, or B, decomposition, C, combustion reactions, D, single replacement, and E, double replacement. You'll kind of have 5 options and you'll have to pick through them. We haven't really talked about single or double replacement reactions yet, so identifying them is very easy. Kind of, if I could spoil the lesson for tomorrow, single replacement reactions always have a total of 3 elements. Double replacement reactions always have a total of 4 elements in them. So with single replacement reactions, it's either one metal and 2 nonmetals and the nonmetal switch, or it's one nonmetal and 2 metals and the metal switch. So if that doesn't make sense, I'll explain it in a little bit. Double replacement reactions is you have 4 elements. You can have 2 metals or 2 positively charged ions and 2 negatively charged ions. So a total of 4 ions, so to speak. And then the positives switch with the positives. Or you can think of it as the negative switch with the negative, but I like to stay positive here. And again, I'll show you some examples of double replacement reactions in a little bit. So identifying the following types of reactions, that's also a skill you need to have. So predict products for these 3, synthesis, decomp, and combustion. I'm not going to make you predict products for single replacement and double replacement. If we had more time in this quarter, or if we had, just like a better non-distance learning type style, maybe we'd get into this. We got into this last year, but we'll just keep it simple with identifying those types of reactions and then also balancing reactions. So let's start with balancing these reactions. Remember, the skill here is that you want to have your elements kind of in the middle. And then the idea here is that you're going to want the same number of B's on the left side, the same number of B's on the right side. Remember that the only thing you can change here is you can only change what you put on these little blanks. You can't change A, the number of A's. You can't change the little numbers next to B's or the little numbers next to A and B here. Those are called subscripts. We don't change them. So for example, to balance this out, I would need to put a 2 here so that I have 4 A's on both sides. But then remember that 2 gives me 2 times 2 or 4 A's. But it also gives me 2 times 3, 2 times 3, or 6 B's. So because I have 6 B's on my left side, I'm going to want to put a 6 here so that it's 6 and 6. So my numbers would be, there wouldn't need to be a number here. Actually, there would. It would need to be 1, right? And then 6, and then 2. That's how you balance a type of reaction. And then maybe I'd ask you a question like, what type of reaction is this? You have to think, okay, I've got one thing, combining with another thing, and they just join together. That's synthesis reaction. So this would be here a predict, be, you know, skill number 2 that we're trying to teach you guys. And you'll have to do these for pretty much every reaction we throw your way. Looking at the second reaction, maybe you can already tell what type of reaction it is. Hopefully you can. It's a combustion reaction, right? And the dead giveaway here is always ends in CO2 and H2O. Remember, with combustion reactions, you want to start by first balancing the C, then balance the H, then worry about the O. Remember, a trick you can do is you can always divide the number of H's you have by 2, and if that number is even, then you won't have to put a 2 here next to the CH or the C8H16 number. Or you can do it later, but yeah, either way, there's only going to end up being a 1 here. So you could have just waited to find that out later, but kind of helpful to know now. So you have 8 C's and 16 H's on your left side. That means you're going to want to have 8 C's and 16 H's on your left side as well. So I'm going to have to put an 8 here to get 8 C's. And then for my H's, I'm going to also put an 8, right? So that way I have 8 times 2 or 16 H's. 8 times 2. Keep in mind, when I put an 8 here and an 8 here, I also change my number of O's. So in this case, from CO2, I have 16 O's. And from H2O, I've got another 8. So 16 plus 8, that is 24. It's 24. Awesome. So then I'm going to need to make sure that I have 24 O's on my opposite side. So to do that, I'm going to put a 12 right here. 12 times 2 gives me 24. And again, that's a combustion reaction. This last reaction down here, this is an example of a double replacement reaction. You can tell because it's got a total of kind of 4 different atoms. We've got Ca, which is one type of atom. We've got Fe, which is another type of atom. And I put these both in green because those are both metals. So what you'll notice here is you'll notice that Ca and Fe will kind of flip. So on the other side now, you'll see that Fe is paired with Cl and Ca is paired with O. Ca paired with O, Fe paired with Cl. And Cl are my nonmetals, so I'll just put those in blue. Here's a light blue for Cl, and here's a dark blue for O. So again, kind of the idea is double replacement, meaning you have a total of 4 things, double replacement reaction, and the metals just flip. Now, this is balancing, right? But anyway, that's kind of a little bit of extra knowledge that you'll need to do as well. Let's talk balancing. Here, we'll just kind of do these one at a time. Ca, Fe, Cl, and O. Excuse me. Okay. It looks like Ca is balanced. You've got one Ca over here and one Ca over here. Now that's probably going to change, right? Because other things are not balanced. Fe, we have 2 on my left side and 1 on my right side. 2 there. Well, nothing there. Cl, I have 2 and I have 3. 2 and 3. And then O, I have 3 and I have 1. It's going to be kind of challenging. Out of all of these, I would pick the Cl to balance first, just because it's 2 and 3. 2 and 1, that's going to be easy to make right. 3 and 1, since it's got a 1, that's also going to be easy to make right. And then 1 and 1, that'll be easy to fix too. So let's tackle this 2 versus 3 thing. To do that, you want to get both of these, the 2 and the 3, to 6. So I'm going to put a little 2 next to FeCl3. And I'm going to put a 3 next to CaCl2. Now, a lot of things just changed. First things first, I now have 6 Cl's on both sides. That's awesome. Keep track of that. But then I also have 3 Ca's. And I have 2 Fe's. Right? So awesome, awesome. Fe's are also balanced. Cl's and Fe's both got balanced there. My O though, 3 and 1 is not balanced, and my CA is also not balanced, 3 and 1. Now this is kind of nice. They both have 3 on one side and they only have 1 on the other. So I can just put a 3 right there. And then those will both be balanced. Kind of cool that by putting one number down, balance two different elements. And awesome. And then of course we know that this would just have to be a 1. So 3, 1, 3, 2. Balancing is one of those things, folks. The more practice you get with it, the better you become. And double replacement and single replacement are kind of nice because they're so related to each other that usually you'll find that if you balance 2 or 3 elements, the fourth one, or sometimes the third and the fourth one, just kind of automatically will balance out. Kind of nice. Okay, down below here, I had you identify the following types of reactions. So again, kind of very similar to, what we did here. This first reaction, I've got two things coming together as one thing. That looks like it is a synthesis reaction. And then the second one, I have one compound breaking apart into two separate elements. So one thing becoming two things. We call that a decomposition reaction. The decomposition reaction, that's kind of nice. It's balanced already. Okay? 1, 1, and 1. But the Fe reaction is definitely not. Let's take a look at this again. Fe, I've got 1 on one side and 2 on the other. And with O, I've got 2 on one side and 3 on the other. So again, I'm going to take this 2 and 3 and balance them first. So I put a 3 here, and a 2 over here. So hopefully you can kind of see what changes I made there. Let's change the color too. That's going to give me 4 FEs and 6 Os and 6 Os. So you'll notice my Os are balanced, but my FEs are definitely not. It's 4 versus 1. So we'll multiply that by 4. And it's 4, 3, 2. It's kind of how you balance it all out. All right, folks. Hopefully this helps. I know I went through this very quickly, so feel free to, if you have any questions, bring them up tomorrow in class. All right. I'm going to call it quits there. Thanks for tuning in and have a great rest of your day.